Hi everyone, Martin here. Welcome to the Inner Loop. And this series of videos is called Wave Shaping. Ooh. This is a new series of videos. I want to talk a bit about some wave shaping. And for the first time in the history of this channel, I've actually got a bit of inner loop code to look at. So let's have a look at this code which is making these sine waves. Here, let's listen to those. That's a lovely, annoying sine wave. So let's look at the inner loop of this code. Here is the sine function. This is the function which is actually creating the sine waves. The next thing I've got down after creating the sine wave is something which is going to fiddle with the width. So let's fiddle with the width of the sine wave. You can see in the code here that the this left f is the left value. If it's less than a particular value, w, and it's greater than 0, it becomes 0. So what that means is that it will start to squash the width of these sine waves. Let me run. Okay, so what you saw there, or you can see here, is the sine wave getting kind of thresholded and cut off. So let's stop that at a particular point when we like the sound of it. So there we go. Now I've chosen a particular point where we've actually thresholded that off. What I'm going to do now is activate a filter. Down the bottom of the code here, I've got a filter. What this filter says is dl, which is the rate, the difference in the left channel, and dr, which is the difference in the right channel. It says dl, if the difference in the channel is greater than some particular margin, then actually you're only going to be allowed to grow as much as the filter value, which is LPF, the low pass filter. So this is a very strange, kind of odd filter. I don't think it's actually possible to do it in electronics. But what it's saying is that if you rise slowly, you're fine. If you try to rise any faster than a particular rate, you can only rise at the rate that I say. So let's apply that filter to this waveform and see what we end up with. Here we go. It's going to start squaring it off now. I've stopped the filter at that point, so now you can see it goes round, it goes down, and it preserves a few points along the way. So we fiddle with the width, we filtered it, but what about if we fiddle with the threshold? What happens if we say, if you're above a certain point on the sine wave, why not be 1? So let's try and square it off. So let's turn this strange shape now into a sine wave, into a square wave. So here we go. Okay, so it didn't turn into a perfect square wave. The reason it didn't turn into a perfect square wave is it's still got the filter on. So let's turn the filter off. Okay, so what you see now is the threshold moves. So our sine wave turning into a sine wave, which we've chopped in one direction, now turning into a square wave. You can watch it coming back now. As the threshold is moving, the sine wave is reappearing, well, the top bit that we didn't cut off. And now it's disappearing again. It's turning back into a pure sine wave. Okay, the last thing we can do is the top of this sine wave, the top of the square wave. When we threshold it, why not, we could make this threshold go down here. So our wave will go up, down, and back up again. So let's fiddle with this, let's fiddle with the value that the threshold actually hits. So I'll stop it from thresholding the sine wave now. And the threshold point is this value t. So t at the moment, which we see on the target here, target is 1. So at the moment, when you threshold it, the target is either 1 or -1, giving you the full square wave. But when we change this target, the top or bottom of the square wave will move to either the top or the bottom. Let me do it, and you can watch what happens. So what you see there is the bit of the sine wave that we've thresholded off is now moving up and down. We've left with a little legacy bit of the sine wave that is as it was. This bit went to 0 because we varied the width, and here, stay still, and here, this is the middle bit which we thresholded to maximum. We're now moving that up and down. So we're getting some really curious wave shapes here. Now let's filter it for fun. We'll choose some wacky shape and then we'll filter it. Pretty wacky, pretty strange sound. I'll stop the filter again. And let's see if we can get a triangle shape out of this. Here it comes, the filter's coming in now. It's got to deal with this jump here and this jump here. We'll try and see what it makes of that. Okay, so thanks to the filter, which is only allowing a very certain step rate, we've now made ourselves a triangle wave. So here we have a triangle waveform. I'll play that one more time. Final thing I'll do is let's roll all those parameters around and around. So the width, the filter, let's roll them all and see if we can make some sound. Clearly this is a synthesizer without makeup. There's no reverb, there's no wave shaping here, there's no envelope here. It's just a continuous tone. But let's see if we can make some sort of noise anyway. Here we go. So here we've got all the numbers, so you can see the threshold value that I was talking about is now cycling. The filter value is cycling around all over the place. The target, which is where the thing goes to, is going all over the place. And the width is now changing as well. So you can see here all kinds of unbelievable waveforms and wave shapes. And because these things are cycling at different rates, the wave shapes are never going to be the same. So I'll let you listen to that. So thanks everyone for watching. I hope you enjoyed that little run through a bit of code. So this was an inner loop of code doing its thing. So from just these few lines of code here, adjusting the width, adjusting the threshold, and adding some kind of non-linear filter, we managed to create all these kind of crazy wave shapes. In the next video I will probably add some reverb and some other bits and bobs and maybe an envelope around it, and maybe we can actually make some interesting sounds. Thanks for watching, and on to the next video.